All right, ladies and gentlemen, welcome back. Hope you're all having a good day. We're going to talk a little bit about 7.1, differential equations. Differential equations are really easy to define. A differential equation is simply an equation with an unknown function, and one or more of its derivatives. That's all it is. That's all a differential equation is. So, I mean, if you think about it, if I had an equation that looked like this, y plus 3 equals y prime plus y double prime minus 6. It's a differential equation. I have an unknown function, y, and I have a first derivative and a second derivative. It is a differential equation by definition because it's an equation and it has those things. Nothing to it. A real famous one, if you think about it, is, let's do dy over dt equals ky. Is this a differential equation? Well, look at this. I've got y as a function of t. This is its derivative. So this could be considered as y prime equals ky, right? Do you agree with that? Now, I'm going to show you something. I don't know how many of you remember exponential growth and decay? But let's think about this for a sec. Do you remember, what was it? It was y of t equaled y naught e to the kt. Do you agree with that? Now, I'm going to show you something. I am going to say, let's call this 1. And I'm going to prove that this equation is a solution to 1. Now, we should probably define what a solution to a diff-EQ is. I'm never going to write differential equations again. It's going to be diff-EQ. A solution to a diff-EQ is the function. Now, what function is it? It's this unknown function from the original differential equation. It's this guy. Okay? It's this guy right here. Is the function that makes the differential equation true. In other words, it's the one that satisfies it. All right, so here's my proof. I'm going to show y equals y of 0 e to the kt is a solution to dy over dt is equal to ky, right? That's y of 0, not y times 0. Well, watch. Well, if I'm going to prove that this is a solution to this, well, this has a dy over dt in it. So let's figure out what dy over dt is. Well, dy over dt is, right, that's just y prime, which is equal to y naught. I'm going to get rid of this notation because I don't like it. Y naught e to the kt times k. Do you agree with that? Yeah? Well, look close. Y naught e to the kt is just y. So this is equal to k times y, or y times k. Now look how it wraps around. dy over dt equals y prime equals this guy. We know that y naught e to the kt was y. Y times k is ky. So dy over dt equals ky is the differential equation, and this guy is the solution. Let's do another one. Let's do another one just for giggles. Let's see. I want to come up with a good one so you guys aren't bored. How about this guy? Let's do an example. Whoops. Another example. An example. All right. Let's show, we're going to show y equals x minus x to the negative 1 is a solution to the diff-EQ x y prime plus y plus 2x. Okay, fair enough? So I am claiming that this function is a solution to this differential equation. This is my differential equation right here. Whoa, did I say plus 2x? I'm sorry, that's supposed to be equals 2x. equals 2x. To show that it is a solution, all I got to do is, notice what I need. I need a y. There's my y right there. I need a y prime. Well, let's find a y prime. Well, y prime, if I take the derivative of that, I get 1 plus, right? Now think about that, because the derivative of x to the negative 1 is negative x to the negative 2. So this is going to be plus 1 over x squared, right? Everybody agrees with that? So that implies that x, y prime plus y equals 2x. Now remember, all I'm doing is showing that this is true. So I'm going to plug in my y prime. So x times 1 plus 1 over x squared, that's the y prime that I grabbed from here, plus y, well, what's y? That's this guy right here, right? This is going to be x minus x to the negative 1. And then I have to show, think of this like a trig identity. Does it equal 2x? Well, this turns into x plus 1 over x plus x minus, well, what's x to the negative 1? 1 over x. Does it equal 2x? Well, let's check. 1 over x minus 1 over x, those cancel, and I end up with 2x equals 2x. Check. This is a solution. Now, here's the thing that's the most important that you understand. We have shown one solution to this differential equation. This happens to be one solution. There are an infinite number of solutions to this differential equations. We get families of curves. We get families of curves. So we have to think about solutions to diff EQs. EQs are families of curves. In other words, there's a whole bunch of them. Curves. We, for now, are just playing with one. Are just playing with one solution. I will show you how to solve some of these. Not all differential equations are solvable. Like it's not easy to see the solution. But there's going to be a group of differential equations that we can solve using a very specific and kind of interesting technique. All right, but for now, all that you're doing, I just want you to get a feel for how these bad boys work. So if I say, show that something is a solution to a differential equation, it's easy. Take the solution, take however many number of derivatives you need to take, and then stick it in the original differential equation, like I did here. Remember, I took the derivative of this guy because this had a y prime. I stuck everything in. This guy was y prime. This guy was y, and then I showed that it created an identity, and I'm done. It's kind of fun. They're not very hard. They're just like little logic puzzles. Hope you enjoy. Thank you for your time and attention, and I'll see you in class tomorrow. That's a brief, quick little introduction to differential equation. Have a good day.